Okay, on to free energy and temperature. So we've talked about enthalpy, we've talked about entropy and how these things favor. And we are going to talk a little bit more specifically about the temperature or the T value in that equation. So there are three essentially types of reactions when it comes to Gibbs free energy or delta G. There are ones that are always thermodynamically favorable or spontaneous, ones that are never thermodynamically favorable or spontaneous, and some that depend. Okay? And it's really just based on the signs of delta H, T, and delta S, and how those play into delta G being negative or not. Okay, so you can kind of think of this algebraically. I'm going to talk about the first two here first. So if something is exothermic, that usually means it's favored. If something has a positive delta S, that usually means it's favored. Two favored things results in a delta G being favored always. So this is always going to be a negative delta G. And if you look at the equation, that's true, right? If I plug in a negative value here and a positive value here, I'm always going to get a negative number. So these are always favorable. Okay, now let's look at the flip side of that. If I have a positive or endothermic reaction, which is generally not favorable, with a negative delta S, again, generally not favorable, two non-favorables end up with something that is always not favored, or a positive delta G. Okay, so this is never favorable. Okay, so this reaction is not going to happen. Now, if it's reversed, like one of them is reversed, this is going to be, it depends. Okay, so if something is exothermic, probably favored, but if something has a negative delta S, probably not favored. So what happens? Well, it depends. Okay, same thing here. If I have a positive, so it's endothermic, probably not favorable, but a positive delta S, probably favorable. Again, it depends. Now, what does it depend on? It depends on the temperature and how big your delta H and your delta S values are. Okay, so we consider these to be temperature dependent. Okay, so these are both temperature dependent. Okay, you change the temperature, you can actually change how important this value is to the overall delta G. Now, if you plug in numbers, essentially, if we can get this value on the right to be bigger, if delta H was not favorable, that would make it favored. So you really have to look at like which one is bigger to figure out if it's going to be favorable or not. So, okay, I'm going to say that again. I'm looking at this one here. If it's exothermic, so delta H is negative, then I really want this value over here, since delta S is also negative, to be really small. So the lower temperatures, it would be favorable at low temp, because that would mean that this value is smaller than this value, which is negative. Now, if I look at my last options here, if it's endothermic, that would mean delta H is positive and delta S is positive, which means this term over here is going to be overall negative. So if I want it to be favorable, this term over here has to be bigger. So that would mean it's favorable at higher temps. Favorable at high temps. Okay, so again, temperature dependent. You can actually figure these out, like I said, just by looking at that equation. All right, so there is a line, right, where it becomes spontaneous versus not spontaneous if it's temperature dependent. So these two are going to go here. Okay, so if it's temperature dependent and I'm like, what temperature does it change at? What you want to do is set delta G equal to 0 and then solve for the temperature. Okay, so finding the temperature at which something is spontaneous. So I might ask you for that. Set delta G to 0 and solve for the temperature. So I would go 0 equals whatever delta H minus T delta S is and solve for T. Okay. Now, here is my warning when we're using this equation. Delta H is always in kilojoules and delta S is always in joules. You have to make them match. Okay, so you have to convert one of them. I don't care which one, but they have to match before you do the subtraction. Otherwise, you're going to get the way wrong answer. And this happens all the time. So check your units. Okay. Now you might be like, why is one in kilojoules and one in joules? Well, the delta S value is usually a lot smaller, which is why it's in joules. So just watch your units. Okay. So example number 7 says above or below what approximate temperature is a reaction spontaneous? Now, if I say this phrase above or below what approximate temperature, you need to give me the temperature. And you also need to tell me it's at this temperature and above, or it's at this temperature and below that it is spontaneous. Okay, so you kind of got to think about this thing up here, favorable at high or low temps. Okay, so example number 7, above or below what approximate temperature is a reaction spontaneous if it has a delta H of this and a delta S of this. Now they're both negative, so if they're the same sign, that means I have to actually calculate it. If they were different signs, it would be always favored or never favored. Okay, so I'm going to go ahead and calculate this. I'm going to say 0 equals, I'm going to plug in my delta H, negative 25.0 kilojoules per mole, but I'm going to convert it to joules because the other one's in joules. So I'm going to go like this. 1 kilojoule is 1,000 joules. Okay, so that's delta H minus T is what I'm solving for. Delta S, so negative 50.0 joules per Kelvin. All right, so that's a pretty easy calculation. You're going to end up with that temperature is 500 Kelvin. So that is the temperature at which it becomes spontaneous or non-spontaneous. That's the line. Now, that being said, how do you figure out if it's above or it's below? Well, I could consult this chart up here, and if they're both negative, that means that it's favored at a lower temperature. So it would be at or below 500. 500 at or below, it would be favored. Now, reason being, if I plug 500 in here, I get 0. If you're not sure, okay, this is what I would do. Plug 500 in, that gives you 0. Then plug in a value lower, okay, so 400. If I plug 400 in here, I would get a negative delta G, which means spontaneous. If I plug in a higher value here, I get a positive delta G, which means non-spontaneous. All right, so if you're not sure, plug those in. Sorry, something just happened. Okay, so I'm going in to now talk about a specific example, water. I am water at specifically 100 degrees Celsius. So I'm giving you a temperature. Now, what happens to water at 100 degrees Celsius? Well, that is the line where we get a liquid to gas, or if we're going the other way, gas to liquid phase change. Okay, so at 100 degrees Celsius, the delta H for boiling, essentially, the delta H for boiling essentially is 40.657 kilojoules per mole. The delta S for boiling is positive 108.96 joules per Kelvin because essentially you get a lot more entropy when it turns to a gas, right? So this graph is actually kind of cool. It actually shows us quite a bit about what's going on as the temperature changes for delta G. Now we know at this temperature, so this is 100 degrees Celsius, right? This is when delta G would be 0. That's my like switch between the phases, okay? Whether it is being a spontaneous or not spontaneous process. So at colder temperatures, T delta S is going to be a smaller value. And as we heat up, this value is going to get bigger and bigger and bigger, which means it's going to become more spontaneous the warmer you get, because the warmer you get, the more likely it is to turn into a gas, okay? Same thing happens, or opposite, I guess, with delta H. Delta H at a low temperature, I have to put in essentially energy, it's endothermic essentially, to get it to go or produce, okay? So at the higher temperatures, you don't have to put in as much energy, and so that decreases. So this is a line where that kind of crosses, and then where those two meet is where delta G is 0. It's going to be spontaneous, things are going to happen, okay? So let's kind of label this on here a little bit, okay? Over here, this increases, and that's because there's more entropy and higher temp. Okay, the hotter you get, of course, the more entropy you have because there's a lot more energy. Delta H vaporization, as you go this way, the delta H requires less energy because it's at a higher temperature, so you don't have to put in as much energy. Okay, where they cross is essentially where it is favored. So we could actually calculate where is that 0, or where is that favored, not favored? Is it at 100 degrees Celsius? Why, yes, it is, because if you go 0 equals 40, I'm going to go ahead and convert that, 657 minus T times 108.96. We're going to get that the temperature is 373.14 Kelvin, which is really 100 degrees Celsius. So that's where it becomes favorable. So everything kind of like goes together there. Okay. Anything else I wanted to label on this? I don't believe so. We're going to talk about in the next one more way to calculate delta G.